So we start today the session on irradiation techniques. Probably when we start with the non-thermal techniques, there is one technique what we discuss about irradiation. So that may be complete outline, particularly for today's session. We start with the even the starting from the how the worldwide trend for the irradiated food and what is the acceptability from the people, right, country to country, and when we're looking for the doses, is there any recommendation or it is accepted that doses for everywhere, and then also looking from the concerns, because still you may aware this one, this technology is there for irradiation, but you cannot find like other non-thermal technologies are quite popular. Popular in terms, it's not about the technology popularity, but using irradiate material is not, because they have some concern, because they need to take the permission from authorized bodies to use that one. Okay, so we're starting again, particularly food safety, food quality, that is the main concern. And nowadays, even whenever we talk about safety, is for the people health, people are more concerned about their health. Even not only the developed world where the trend is emerging one, even developing country also looking for that one. Okay, whatever we consume, or whatever the product we are consuming now, they are safe to consume. Okay, if something is going to be that is permissible above the permissible limit, that is not supposed to consume by human consumption, we get the restrictions not to allow the food to enter or even the sell in the market. And particularly last session what we see are different techniques, different methods, and getting the popularity, because every methods have their own advantages, disadvantages. Sometimes some techniques are more suitable for particular category of product. So based on that one, we are going ahead with the safety and preservation side. And now I believe now you have that impression. Now we like to preserve the product. Preserve the product means we are maintaining the quality, but at the same time extending shelf life is the purpose, but we do not compromise with its safety. That is also the concern is there whenever we like to use any technology. And there are a number of benefits what we discuss even about the non-thermal one, because whatever undesirable changes what we found the maximum size happening, that is with the thermal processing, because non-thermal means we're not using the directly heat treatment. And that's why the nowadays if you see in the recent trend in the last 10 to 15 years, there is a quite popularity going among the non-thermal processes for the food processing, food safety and quality side. So yes, the consumer what will depend, they want the product like a fresh like product. So it's supposed to be natural. So they believe it's a product, though it's a processing, but it's supposed to have fresh like characteristics, healthier. Whatever for what purpose we are eating that food, it's supposed to be there, safe to eat. And that's why the reason whenever we talk about a non-thermal getting the popularity here. So in this one technology what we are discussing more about, that's a radiation treatment. Okay, so irradiation what we even in the briefly what we say, we have gamma rays, X-rays, that what we are using. That's one of the popular irradiation techniques in terms of product safety and maintaining product safety and product quality, because it is effectively preventing microbial growth. Okay, that process. Even of course that microbial growth, that way we also we can change here what doses we are applying, and then we need to link that doses. Is it the permissible for the human consumption or not? They maintaining the quality. And other thing what we looking always, there's supposed to be minimal impact, because what I am talking here, fresh produce. Okay, so fresh produce means we expect for the product when we buying that one, it should be alter or changes with their composition or any biochemical changes with the product. So now the irradiation techniques particularly, they commonly used for harvested fruits and vegetables, even they are gaining popularity in grains, okay, as well as spices. These techniques are quite popular now, the spices and grains category as well. And always one thing, whenever irradiation we are talking, the concern about the doses, okay, what type of doses and what may be the doses range we can see. When we look for the history of the ozone, we can coming on that one, how the changes happening in worldwide scenario to application of that practices. So when the government organization or like FDA from the US, when they're looking for that one, they look at factors when we're using that particular doses. Okay, it is up to a certain level, it's okay, we are extend the shelf life, but after consuming the product, is that some effect on human health or human body actually? So that also looking for, and based on that one they permissible, okay, we allow up to this one, this range of doses, and country-wise it's change also. So now lot of countries they are allowing the practices to use that food irradiated product. So but make sure actually whatever permissible in India is not essential, it is permissible for another country. Okay, that's one clear thing here. And mostly types of fresh fruits, vegetables, spices, on even meat product, poultry product, seafood, everywhere they have the application. Because now if you remember, we have the categories low dose, high dose and medium dose, and like when we talk for the high dose, it's like sterilizing the product, okay, inactivating or killing the microbes which are responsible for spoilage. So each category now, from the fresh fruits, vegetable, meat product, poultry product, or even the grains, they get in the popularity one. And so when we talk about the food irradiation, that's we're targeting the food, exposing food at specific level of energy and to giving with the doses for a specific period even. So what exactly that one, the food irradiation techniques here prevent spoilage to stop your growth of microorganisms, okay. And now what we consider, they initially come about 60 different types of food, okay. And now you could be aware about world, there may be more than 200 countries, and still we can say some countries still have the reservation about the product, okay, irradiation product. So some countries, so more than 40 countries, they are allowing the product, irradiated product, to come in the market and sell in the market. So there are three definitions coming in that one. First one, radiation, that's the radiation, we can say the emitting the radiation waves, that's energy for the electromagnetic distribution. Irradiation, the process applying radiation to the matter, in our case we say the product, our product, and that's the food radiation because we are applying the radiation on our food one. So ionizing energy into the food product. So coming directly on the product, we may look towards how the food irradiation is applicable to the food. So little bit history side. So in radiation, what we say, we are employing ionizing radiation or electron beams. So when I talk about X-ray or gamma rays, actually, to enhance the safety of the product and extend shelf life by reducing or killing the bacteria or the microbes responsible for the spoilage. Okay, so what we say, up to the certain doses of the irradiation, we not consider okay, it will changes the product quality in terms of their texture, flavor, or nutritional one, but it is completely linked with our doses. We may see in some examples when whenever we go for the higher doses and the composition of the product, it completely changes here. So initially 1950, particularly initially when the irradiation they tried to use in the food product, that's European side, they start to use the application or started the trials how when we use the irradiation product and how it is response from the human consumption. Then after that continued this one, because still I telling this one because now we are in 2025 and still there was quite reservation, and every time we read, every year we get information where we are going for this one. Then to enhance that one, when they're looking for the application, whenever there is something we're looking, okay, we need to preserve the product. The technology is supposed to be cheaper and it should not alter the properties of the product. So then after that there was a joint committee between World Health Organization and FAO. We start to work on that one actually to see the effect on irradiation the product. And then the committee actually what they concluded initially, that's up to the doses up to 10 kilogram, okay, does not have any toxicological or risk for the product. So initially the recommendation was the low doses up to 10 kilogram. So startingly up to they were permissible, not to beyond that one. And now you could see some country guidelines, that one they are also playing that one. Okay, we do not want to use the product beyond that one. Then continue the study was going on that one, so because it was initially early 20th century one. And then based on that one, FAO and WHO had when they come here with the atomic energy one, because India also they are responsible body who is using that irradiation technology, who are licensing that one, that is a BARC. So they come here that they come in the idea here that this technology is a safe for the product and it's not any harmful effect when consumed by the human and even by the animals. Some products maybe they are looking for the animals. And more than 40 countries or more than about 50 countries, they are accepting or they are using now the technology. Or sometimes some countries may not use because it links with the atomic and with the radioactive materials one, but they allow the product to import in their country and sell in their country. So mostly what we see here, we use the gamma radiation or X-ray radiation. The idea with this one, they have low mass and they have high penetration power, so they can penetrate little deep. Okay, so now you can come here. We have the huge production of the fruits and vegetables worldwide, but the irradiation product is still in the thousands tons. So that is the quite old one, but you can see here the number what we process the product with the irradiation technology is not high enough, still in the very limited number. Like a recent one initially, because there is some reservation, some concerns with the technique still now. Like in 20th century initially when the technology the peak, so in the whole European Union, if you consider your processing is less than 10,000 tons, it's not a big number for the processed product. So even now you see it's like countries who has huge production like fruits and vegetables like Brazil, China, they are leading for this one now because we have the huge production and we need to protect the product by using the technology. So you can see here the Brazils or even the Mexico, and particularly now the new application actually what we see in the tropical, particularly in the mango even in the India, in Brazil or Mexico, the application alongside with other foods is more popular nowadays. So in Asia Pacific, when you see here still in the irradiated product, who is the leading this one? This is China. Okay, they have the maximum irradiated product for the consumption or for market availability. Rather than for India, up to now, we have the capacity here about 10,000 ton for the process. It's mostly spices, dried vegetable, and the onion, particularly, and potato, because the idea here to stop the sprouting. And mangoes nowadays quite popular because even India near the Washi they have the center where they are creating the mango irradiation of the mango. Then we can come here some countries, but one thing you may notice here, now the production of the fruits and vegetables go with million tons, okay, but still the values what I am showing here is in the thousands. It may be countries like Vietnam, South Korea, Indonesia, Thailand. The number is not that big for the irradiated product. So concerns are there. So sometimes the agency also looking for this one. So make the awareness for the people that making sure, okay, when you're licking the product, is not harmful, because whenever they come, it's a radiated one, they get the idea, okay. But now there are also one protocol from the agency they like to make here. Whatever irradiated product, they are supposed to have one logo on this one. That product is irradiated product. So application side, if you see the some country like India, we have spices, mango. Some country even go for the meat, poultry. Like Indonesia, we can see here frozen fish or shrimp. And like a Thailand, aware about that one, they are more towards on the fruit side. Because fruit side here, the idea is to increase shelf life and delaying the ripening. Okay. For example, mostly studies and mostly research, even the mango, strawberry, you can find this one. And for our irradiation one, even the frequency side, what we say, gamma and X-rays, what actually we mostly coming in that category here, gamma rays and X-rays. The idea here for why we selected this one, it has the properties of deep penetration inside the product. So we have E-beam, gamma rays, and X-ray. So of course, resource from where we are getting for the gamma rays is mostly from the cobalt 60, from where we are emitting the gamma rays. So for a gamma rays, that's from the cobalt 60, that is where we are getting radiated. For X-ray, we have the energy level like about 7.5 million electron voltage for some countries, and for some countries up to 5 million electron voltage actually. And electron beam with for higher intensity, it's up to 10. Now it because when we're deciding the doses, they can use that one actually with the calculation part. So the high energy electrons, gamma rays or X-rays, have the property to inactivate bacteria, spores, fungi, okay, and indirectly breaking their molecular bond and destroy it and make the product safe. And particularly whenever we look for the the radiation, what we see here, they are the sometimes powerful source what we require the radiation to inactivate the activity of the bacteria, spores or fungi. Then importantly, the most guideline, the country wise or when the food one, FDA or FPO, whatever we say here, there is always recommendation what doses, and of course up to low doses there are not much concern. So in low doses, what we say here, we can control insect with maturation stages, means delaying ripening in some cases, and even the stop the sprouting for the product. The medium doses like a pasteurization, what we say 1 to 10, of course extending shelf life, reduce microorganism level, and the doses, high doses is like a sterilization. Okay, so it's like a, if you consider that we are canning the product, so mostly for the spices they are using. Now whatever the study now you look in this one, they are more concerned in scientific study. You may find you the medium and higher doses, but whenever policy making come, you can find that they are very strict with the low doses for this one. So there are some typically information or recommendation by FDA, like some products like maintaining freshness or fruits, that studies coming on this one for insect, and they come for some fruits and vegetable should not exceed than 1 kilogram. That's our lower dose. Even some poultry cases, that is recommended to control the microorganism. So you can see here, from one thing is very clear, like a 3 kilogram. So even you are the low to medium dose only we are targeting here. So frozen meat and chilled meat is also the less in the medium range, 4.5 to 7.5. So mostly cases their recommendation going for a higher one, because there are the chances sometimes the country wise they where you want to send a product, they not have ready to accept this one. Still there is a chances, because what we consider here, whenever they go for the higher doses, maybe the process may be faster, at the same time elimination may be faster, but there may be altering effect, and still there is a concern, because for irradiation they are linked with the even the human, when they consume by human is still safe or not. In the even the gamma radiation, when we say about the cobalt 60, that's a sprouting, eliminate, and that is a quite popular, still popular one. So particularly if you consider this label here, okay, if your product is irradiated 1, even the FDA have the clear guideline. If your product is treated with radiation, consumer must know that one. It's not something the product you are selling and without their awareness you say the safe product something. They must know before making their decision or opinion to buy it not. So they call it a radula symbol, where radiations particularly. So and like to keep the word treated with radiation or treated by radiation. So people aware. So they're not still now making the doses. Okay, it's a higher or lower, but at least a consumer know that one. Okay, I am buying this one, so it is my. I am aware the product is safe and using for this one. Oh, and particularly in the bulk, sometimes it's individual products come in like a meat one single packaging or something, or sometimes it's like a bulk one. So your cartons comes and you are making the labeling. Okay, this is the radiated product. And most of the times such regulations, because those working in the food industry, sometimes FDA regulations that may be mostly followed by the worldwide, because whenever we some countries just consider okay that is one of the guidelines, though we are not following, and whenever we look for the product made for the export, some countries they don't have the protocol, they follow okay what FDA is saying without testing or something. But mostly products they coming with the labeling nowadays actually, because mostly times the product what we're using in India, because we have the facility and they have the near Mumbai they have some facilities where there are onions, potato, even for the mango going for irradiation, but you did not find a product available in the local market. Okay, most of the time we not found the onions, they don't have the sprouting coming, even if the storage one. So they are targeting still for the product, because the purpose here they extending the shelf life of the product and targeting the consumer market. When the cost was, when we discuss, actually that's my personal experience with the people from the bark. So what they considered per kg, the cost of this one is not that expensive, even less than 50 paisa, 50 paise. So because it's like a bulk treated product, actually, even if you consider the whole storage of the onions, if you aware this one, it's like a chal, and you can treat it in the same chal with the irradiation one. So cost wise is not just about the awareness and accessibility. So when we see here, there are two ways actually. One we say the direct and indirect. Okay, direct and indirect. That's the irradiation effect on the microorganism. Initially, what we consider here in a direct side, that the ionized radiation kills the microbe directly, okay, damaging their cell. It's a directly one, what we say, it's hitting on the direct, okay. So incoming photons, when I show the X-rays, actually hit the atoms of the microbes or the food molecules, and it's most towards the, in real case, maybe we always consider the indirect one, but that is one way to consider here if it's a direct one. And because the electron collide with the product and with the neighboring, and it will going to here change their or break their bonds, bond breakage, and it may interrupt their cell metabolism, disturbs and killing the microbes. So that's what we assuming here, direct. But in the reality, every product have the water, not only the direct cell attacking. So that's why the terms coming here, the radiology, radiolysis. Okay, radiolysis is like where the water treated with the irradiation. So mostly food product we have water molecules. Water molecules. During the process, what we consider here, there was free radicals during the radiolysis process. That's the water treated with the radiation happening actually, and we consider here that the free radicals, whatever processing during the process of irradiation, they are quietly reactive and try to form the stable product, and then they will combine with another oxygen molecules working as a oxidation agent, and then that process here helping here to damage the bacterial cell component and deactivate or killing the microbes here. So that unstable free radicals react with the bacterial cell membrane and to damage the structural bacteria. So it may helping here to killing the microbes and extend the shelf life of the product. So mostly, though we say here direct and indirect, direct is a more theoretical way we are consider, okay, directly attacking on the target, but is in reality is not. Reality we can consider that is the correct one, actually indirect way. And like most of the times actually in the food one we consider, okay, food is any fresh produce, is the main one is the water, sometimes 80%, 90%, but with water there are another lipids, protein, carbohydrates, vitamins, that are all ingredients also there actually. And when the radiation energy, actually the degradation will come with the water, that's aqueous water in the product, with the food one they call it a radiolysis. And particularly product with the water, okay, with the water one we even call it a radiolysis product. So when we come here, particularly the properties of the food, whenever the dosage is higher, up to when we go for the permissible limit, whenever you found a different studies, okay, up to certain level what changes, up to certain low level we are inhibited the growth of microbes or stopping the growth of even controlling the microbes. But up to certain level, when we go for higher doses, there are some changes happening with, and the mostly studied nowadays, even in India, they're looking the effect of higher doses, how it's affecting the quality of the product, safety, and the challenges here up to certain lower doses, we not found a lot of alternation. But when we going for a higher, the alternation may be desirable or sometimes undesirable with the product one. And even that's why when we say sterilization level, even it may go with the nutrition loss. Sterilization level, you may consider here, we are talking about the high dose, up to more than 30 kilogram one. So they may be killing, process may be faster, but at the same time, if you consider our treatments, actually whenever for higher process become faster killing this one, but undesirable effect, the products which is sensitive for this one, that also happening with the irradiation process. So just to get idea here, when we say here some components from the food, like how it affects it by the carbohydrates, lipids, proteins, or water. So most of the times what we say, when we have the irradiation, actually the carbohydrates are broken down, easily broken down, and even depolymerization reduce the gelling, and it changes the functional properties from the starch and gums. But during the irradiation, one factor they consider here, effect on as a sugar, is not considered here, mostly studies actually. For the lipid one, they call it, because absence of oxygen here leads to cleavage of interatomic bonds, and the challenge again when with the lipids, like if you use for any fatty product, it gives smells, okay, it's odor. So if there is some studies actually when they use the fatty fish, fatty meat, actually the rancidity, okay, sir, of flavor that is coming with this one. For proteins, we consider if it's a low dose, it's not anything affect on the protein. Okay, they're looking for the if changes in the protein or things, the dose is supposed to be high. For low or medium, is not have any significant one. And even for some enzymes, they are surviving the high doses even. So now if you check here, up to now there was a study in the researchers side, some countries they allow up to 50, but some studies is still going on above that one. If we go more than 50, is that something happening that we can inactivate all the enzymes, yes or no? If that's the case, what about the effect of other properties? So mostly studies in research lab side, they may coming in this one. Okay, even for the water, they may produce here hydroxyl radicals during the irradiation side. And even for the vitamins, that is the main concern about the food, and most of the times they are quite sensitive, okay, process. So for if you like to preserve the vitamins, it may be recommending for the lower doses. But now challenge with this one, you like to preserve the product, extend the shelf life, then as a researcher the idea here to optimize the condition for changing to product to product. But for irradiation, another story is that one, it's not about the product consumption, it's directly linked with the human health as well, because it's consumed by the human. So that's why you found here the research is going on, but not up to the that much actually, because as a human will directly link with this one, irradiation studies. But mostly times the doses up to low level, low or medium level, still some countries open up that one. But going beyond that one, still some countries, okay, they are coming, okay, we are allowed up to 40, 30, but not beyond that one. Okay, so that one, whenever irradiation we say they have the effect, but one thing else consider when I say the effect is more linked with the doses, more linked with the doses. So when I say the loss of micronutrients something, you try to get idea here. So the safest level what we consider, they always come here the low, but we have the limitations, some properties we cannot alter or not effect on this one. Even for the protein, lipid and some carbohydrates things, some even they go up to that more than 10, more than medium also, there are slight changes, but there are some sensory alteration, and sometimes the smell or off flavor that also coming that one. Some studies even they come here for the bread that is made by the flour, because what they coming here the flour using for the bread, they coming with the normally and use treated with irradiation before making the bread, and they found here niacin concentration is higher for the bread that is used by the irradiation one. But even in the irradiation product, some sensory qualities, because at the end people looking to purchasing the product, one thing is maybe a very strong statement, that is what we say, it's not something where we say that irradiation we can use for each and every product. It's not practically feasible one. Like when we talk about high fat content like fish, fatty fish or fatty meat, here develop undesirable odor or flavor, because it will accelerate the acidity during the process. Even at a low dose, particularly for the fatty product, and some fruits and vegetable with the doses, they need to link here how much loss of nutrition, if the sensory one like a firmness is how they affecting on the texture, and they found some fruits and vegetable with the doses quite drastic changes happening with their surface firmness. Even the high protein product, meat or poultry, they found if they give at do at detergent at room temperature, they getting the off flavor or odor change. So there are sometimes they have the another studies even they may be playing with the doses actually. So there was something when we see the off flavor and rancidity, there are something high fat beef here, they come here not to go more than 2.5 to extend the shelf life rather than high dose, because even when you go for high dosing, there is chances of the rancidity for the product, for fatty product or egg or dry egg. So the range around less than 3 kilogram, that may be for the fatty products to avoid the rancidity. Even for the cheese product up to 3 kilogram, because when we going for a higher one, the challenge with the rancidity, the smell, okay, the smell for the consumers, they not accepting that one. So these changes, particularly whenever they look for the rather than doing at the room temperature, even they can do that process. That may be some alternative. Some studies still going on, rather than room temperature doing the irradiation, which you cannot go at the a refrigerated or chilling temperature or freezing temperature to check then, or at the same time what type of packaging they are packaging methods they are using, or even the irradiated product, but rather than store at a normal condition, go with the control condition to control the transitivity. Okay. So now for this particular technology, what we consider here, they have the both way. It may be positive or negative one. Mostly times, so playing with the doses is the very important here. Mostly the sprouting doses, they are with the low doses particularly, they are useful for the sprouting. That is the more concern. Mostly products what they are selling in irradiated one or commercial side. I'm not talking here the research side. Research side we can found the products from the mostly food table they are targeting for the research side. But the commercial side, what the product they are looking here, those who are changing to sprouting very faster once they get the favorable condition, and at the same time deactivate the microorganisms. And mostly we can say, okay, how we are doing the process rather than direct, because maybe indirect way to using the irradiation processes. And whenever the doses go more than 10 kilogram, they need to, rather than the quality, but the sensory property is quite important here, because we expect there some unexpected changes, sometimes some physiochemical changes, and even your sensory properties maybe changes from color to you have the firmness and that type of properties. And even this one more than 10 gray, particularly high dose. High dose, we can consider it high dose is like our sterilization process. Even the structural changes with the product. Even particularly in the radiation side, this also link here to reduce the polymerization and increase the viscosity for the solutions. Even some morphogenetic changes, that is what we are targeting, inactivate or killing that one, that is happening here. And somewhere there they found here that there was higher changes, particularly thiamine, vitamin C. This is quite sensitive with the doses for the product, for irradiation product. Now when we look here, some studies what they do for the irradiation, particularly this mango here they come with a low dose. Actually mango treated with a low dose, just like a 1 kilogram. Idea here to extend the shelf life means delay ripening for the product, and with the appearance and things. And then another one, they go here 1 gram, 1.5 gram and 3.5 gram. With appearance side, getting the optimized one, even they go for the higher doses. The quality of the product is not up to that much. Okay. Even if you consider here 1 or 1.5, okay, even if you go for 3.5, then it's not giving you the proper quality of the product. So the mostly cases they optimize, getting correctly optimized one. Then here when studies on the strawberry mostly found, I not come across up to now the product in commercially in this one, okay, strawberry one. But in the research side they are looking the effect on the strawberry even. So they get the radiation up to 0.5 and 1 grade, that's a lower level. And where what they found here, When even go for the 0.5, they able to extend shelf life, whatever the shelf life for the strawberry at conditions extend by the 3 days more. And even the rancidity flavor, that off flavor is not happening during the strawberry. So even another one, like you can consider here again the strawberry storage, but here the using the doses 1, 0, 1, 2 and 3 and coming with the appearance, because there in the packaging side when it's a controlled one without treatment, it's like completely mess up the leaking the water from the leakage one. Even one is not show the quite better result here, that lower dose. So mostly even in the 3 also not, but in the study what we found in the reporting side, that's a 2 kg that is able to extend the life of the product up to 2 weeks. But with the whenever strawberry we consider here the temperature management also the important here, because we cannot tell the when we are using the strawberry and you can store at atmospheric condition. Okay. Then there are mandarin even for the less than 1 kilogram, less than 1 kilogram. We have the product this way. So even somewhere here some characteristics of the weight loss or decay with the product, they also we have the studies, and with this one they try to link with the appearance, texture, the decay or weight loss, okay, to link with the different combination of doses. And they targeted here, you can, one thing you can find here, that all look to see here for the low one, because it's mostly country they are permissible for the low doses less than 1 kilogram. If it is successful with this one, we get optimum condition for the storage one. So without getting much permissions or much information, it's easy to apply in the market directly. Even for the GAWA one, they have this one, and just to get here the irradiated one, the GAWA after the 9 days of storage. And GAWA also the quite sensitive fruits, and this shelf life is quite low one. Even after 6 days is showing the symptoms of the damaging the product. And after 9 days, okay, it's like you are completely loss of the product. But with the like a 0.2, even 200 gray, just like a 0.2, less than 1 actually. That's effective for this one. So sometimes some fruits and vegetable, particularly fresh fruits and vegetable, is sometimes go less than 1. But like a product like poultry, meat, or even the processed food, they may go for the higher doses one. Now for the bamboo shoot, even they look here the products with the irradiated one, just to check with the all physiochemical changes, including decay, firmness, phenol content, respiration like CO2 release, and even the sugar content from this one. And what is the satisfaction level? They are able to reduce the level from the weight loss, even the decay rate up to certain level, like even from the decay. And for this one they already stored up to, the study was they did for the 28 days, means up to 1 month, and still they are in the acceptable condition. So particularly whenever they looking for the factors irradiation process, so importantly what they look here at what is the surrounding condition of the product. Okay, when we have the irradiation process, much water, because water will tell us the water activity. So what is the dominant process here. Even the temperature condition, what process we are doing this one. So these factors actually they look here whenever they're looking for the process for the irradiation process, and continue this one. If that after processing, if we're looking for freezing temperature, chilling temperature, or ambient conditions, particularly when we see about the potato and onions, because they both are treated in the ambient condition in our case also here. But some products like meat, poultry, surely it is recommended that they go with the freezing or chilling temperature. Okay. So when about the irradiation, what the food industry suppose still is a challenging one. You can hear or whenever you read this one, still is not accepted easily worldwide. Okay, so that is the one consideration people supposed to get here, that aware this one, that all radioactive or irradiated product are not risk for the health one. Okay, when we are using concentration to low, which not harmful for the human health. Okay, and in the radiation actually, particularly when the dose, the speed, the timing, that is also important one, up to what level we are keeping the product, what may be the speed for this one. So even initially, if you see the history from that one, 1950 started to use of the irradiation, and still up to 70 to 80 years, the progress is slowly actually. Whenever FDA coming with some recommendation, and they come here, some processes, some products, they coming stepwise. Okay, now this category of product, if you go up to certain level of doses, are safe, free from pest, parasite, or disease making one, and they can go with that one for the product quality and consumption actually. So, and particularly it's still from the researcher side, because when we are listening the expert, particularly from this area, the one challenge still about the awareness. Is consumer ready to accept this one? And if they making the awareness that one, okay, up to low level of doses still is a safe to eat. Of course, worldwide they are doing this one, and then some trials still going on up to higher doses when we go up the sterilized and even beyond that one. And every time we see the regulations, what we have this year, maybe after 2 years they come with some recommendation, okay, the particular product, even you go for the more than this one, and that is safe for the human consumption, or no health risk beyond for this one. So that's why you say here, some product previously restricted in US, because of that one, now they are allowing that one. Okay, now the product, but when it's coming with the human health, the trials and things, it may take the years to come in this one. So no one want to play with the at least developed world to see, okay, allowing the product, and they have the risk factors with this one. So nowadays, particularly Asian parts, particularly if you consider from the research from the Thailand, particularly industry from the Thailand, even from the India, rather than potato and onions, now the second important fruits they are targeting like a mango. Because the demand for the product high, but shelf life, the extended shelf life always the challenging here. And so always think for that one whenever you try to product education, awareness, sometimes. But what I will consider it, when the body at coming with that, people have the impression that one, when body emit the radiation, the product radiation will coming from X-ray, gamma rays, and when it's this one, it may directly make our health risk actually. So challenging also that part actually, people are ready to accept this one. But there are nowadays the studies actually, one survey they did, and when they're looking for the awareness, when they give the awareness for the people, okay, we creating this one, that may be the study happening and that may be the output from this one. So mostly consumers ready to show their positive response, they can purchase and if the available irradiated product in the market. So of course there are a number of applications, so we just showing some applications how the worldwide scenario change for the accessibility of this product around the world. For example, the low dose up to 2, that is quite acceptable now. So the product which will low dose is worldwide, so even the export industry, they can easily adopt this one. And because it has showing minimal effect on the flavor, aroma, now we see the fatty and other parts, proteins, whenever we go for higher, then only we found alternation or changes happening. Then they come here one idea, why not these techniques rather than going the normal condition, it may be go with the modified package or even the controlled storage practices. So just to extend the shelf life, taking the benefit of two processes, you are irradiation at the same time you are the storage practices. Okay, so like onion, garlic, where the sprouting we can consider here, or tamarind, they come here commercially available, and in the product looking for the export side, they commonly use this one product now. Even from the India actually, whenever we saw the onion, mostly for the onion, because we did not start here in the Indian side the garlic, because I not come across from this one. Why not? Because we, as we are aware, there are limited centers still now working in that area. Okay, so even from the leafy vegetables from the US now, they approved actually. So one thing you can see, if you see the world papers and today's paper or today's documentation, you found a lot of changes happening. Maybe in previous studies you found, okay, they restricted its product, but now they're open up with the low doses. Okay, just go with the spinach or leafy, because there are sometimes due to there are some contamination due to E. coli, and to prevent from this one. For some countries like Japan, they give the permission up to less than 1 kilogram for this one. Just idea, because their idea is here to prevent the sprouting from the product. And even for the potato from some countries like just insect disinfection. So now one thing with the clear with the irradiation process, what we come, we cannot say that's very strict recommendation for this one. Some countries make the recommendations more linked with the health concerns. Okay, sometimes they not want to go for higher doses, because still some studies with the human health may be recommended for this one. Once they approve, they may come with it sometimes, but mostly found with the spices, they are still coming with the little higher one, up to 10 kilogram, some recommendation. But when I say the sterilized one, is like a still in the debatable questions, shall they accept or not. But with the coming result, coming solutions, maybe combination of another techniques with this one, and come with the potential result for the people, it may be changed. So particularly for irradiation, you may come with, sometimes you read some recommendation even from the bark, particularly for the food category, what may be the recommendation doses. One thing we clearly get here, higher doses process may be faster, more effective even. But what about alternation, and what about their effect on the human health? So we start with the irradiation process now. Okay. Okay. Thank you for this one. And any queries, questions?
Are there any commercially available irradiated products in India?
Uh, Frankly, we have the techniques, we have the facility available, okay? But mostly product what we aware this one is for looking for the export market. So we have the facility, okay? We are doing the irradiation process. So for example, if you aware, because the center who is giving the permission to use this system is a BARC from Mumbai, okay? So if you want to use the irradiation process, irradiation techniques, you need to get the license from them. And they have some vendors, they will set up the system for you for the product with all guidelines. So India mostly, if you know about Nashik, which is the famous for the onions, okay, they have the facility for the onion and mostly targeting with the export. Then they have another in the Konkan belt, we have the mango, lot of mangoes, the facility for the mango, but the mostly products for the export market. Okay, we have the facility, but not available in the market, local market.
Thank you, sir.
So, sir, I would just like to start with your last statement, which you said like the higher the doses, the higher will be the irradiation,
Yeah.
or higher will be the sterilization effect which will be seen.
Yeah.
So, as a regulator, so what should be the consideration that I should take in like into my mind before deciding the upper limit, upper high limit for the commercial level?
Particularly for this one, what to pay, because we like to bring the product as a commercial level. Okay, that's one idea with this one. And if we targeting the states, US, and they come here up to 2 kilo gray, we have no restrictions. If going between 2 to 10, if we have restriction, okay, we need to give the your complete study, and they have the reporting, okay, up to 10 kilogram with the product is not have the any adverse effect on the human health. So it was really suggesting that one we need to work in that window beyond that one. Now in the researcher side, what I come across actually, they work in some studies even go up to 30 to 50 kilogram, and they found some excellent result for the preservation side. Okay, but the lacking is they cannot make it technology commercial available, because we like to go get also the study related to human health, how it's affecting that one. So I still believe in this one. If you're targeting what particular country or particular product, so that the guideline that up to 2 kilogram is the acceptable, maybe that window may be playing better rather than going higher.
So I have a second doubt which is related to this thing. So we talked about higher safe limit, right?
Yeah.
Let's talk about the lower safe limit also.
Yeah.
So we generally read about one experiment in our bio books and that. So in that experiment, so they take a infectious strain, that salmonella one, which is very common in meat, and then they heat treat it and make the bacteria die.
Yeah.
And then they take a non-infectious strain, and then they keep in the same you can say the vessel, but that also started behaving like a infectious strain. So when I treat my product with the lower safe limit, like lower level of irradiation and then lower gray, so if the nucleic acids are not damaged properly, then it might convert even the non-infectious strains into an infectious strain. So with that, keeping that thing in mind, so how we can trust irradiation?
No, my concern is now, it's not I'm talking about the product safety. Is here the main concern about the irradiation after the Japan event, okay, nuclear one. People more concerned about the stresses of irradiation in the product. So we not hear about the food safety side. We are fine actually. They are looking here the stresses of the irradiation actually for the product, and that's why the human health when I'm talking about, it's not I'm talking about if there are microbes or any other factor, they may be still affecting the quality on that one. the people more concerned about the, if there is a irradiation and they concern, they may be stay for the years. So that was the mindset particularly for this one, irradiation concept.
Okay, thank you, sir.
Yeah.
Good morning, sir.
Yeah.
Sir, there is some terminologies when it comes to irradiation.
Yeah.
When the dosage of radiation is in between 1 to 10,
Yeah.
it is termed as radiorization.
Right.
When it is in between 10 to 30, it is termed as radicidation.
Yeah.
And when it is above or when it is in between 30 to 50 or more than 50, it is termed as radioprotization. So when I want to preserve a food product, how come I know which frequency or which dosage suitable for my product of interest?
No, particularly if you consider here the fruits and vegetables, they always go with the lower side actually. Even mostly studies the recommendation even the less than 4 to 5 kilogram. Okay, for meat product is little bit higher side, and the spices particularly if you see the 10 and around the 10 and above 10, but the sterilized one when we say the above 30 or highest dose, still in the research side we can do that one, but still the acceptance from the or approval from the authority still is in the question actually. But the product what we're looking for, if it's a fruits and vegetable, it is always recommended go for the lower side, even some studies even less than 1 kilogram. But processed product may be little higher and spices little higher because it's a dried product.
Okay, sir. Thank you.
Good morning, sir.
Good morning.
My question is, sir, does irradiation technique delay the process of ripening in fruits?
Yes, mostly for the mango what we're using, that's the idea was to dealing the process actually.
Okay, sir.
And that's mostly because dealing that's Thailand, particularly Thailand and India. We have that facility
Yes,
because
sir.
we are the one of the biggest producer in the mango, and they're trying for the mango. And for mango, they are looking for going for the higher doses, but the challenge the same one actually.
Yes, sir. Yes. Okay,
Is
sir.
it accepted by the outside or not? We get the approval.
Okay, sir. Thank you.